Okay, great. Battery seems to be okay. So let's talk about chapter 3, the second half. So the first half is about ratios, and you can manipulate ratios. So let me do this real quick and just say chapter 3, ratios, graphs, puzzles. Starting to see how you can take basic information and solve some puzzles, and really thinking about the physics and this is a big step. It's very doable, so it's not a huge step. I've tried to ramp you up. In the first part of chapter 3, we talked about some definitions like S, average speed from any earlier to later, is defined as the distance traveled over the time it took between those two moments. We had the average velocity is different. If we change direction, it's the displacement, just start to finish over the time. And we had average acceleration defined as the change in velocity earlier to later over the time to make the change. Remembering that the change in anything, call it B, from earlier to later, is the later minus the earlier. Sometimes we can just see it and whatever that means. And so I'm going to talk about some general things about graphing and then make it specific to describing motion, the basics. So the change in velocity is velocity later minus velocity earlier, etc. The other thing I'm going to point out, and what we're going to see, is that these can be seen as slopes on graphs. So change of one over the changing in the other, rise over the run, slopes on graphs. And we're also going to see another important thing on graphs, and that is the graphical area. In calculus, well, I'll tell you that after I write this out. So we're going to be more focused on these two when we get to graphs. And notice that if I multiply both sides by delta t, which we'll do in chapter 4, and really build up with chapter 4, bam, and then the first part of chapter 5, man, you are ready to go. I multiply both sides by delta t. I've got the change in x meters is equal to, say, meters per second times second. Meters per second times second is meters. And you start, initially you memorize a few things, but then you don't rely on memory. You just look at it. It'll tell you what you need. Multiply by delta t here. And I've got that delta v is a average earlier to later delta t. Units, for example, meters per second squared. So that's why it's good to play with chapter 2. Stuff gets more familiar, easier. Times seconds. That becomes meters per second. And that is meters per second. Or miles per hour or whatever, kilometers per hour, like the rest of the world. So when I see this, I also see this in my head. I can see I can rearrange it. And you can rearrange it however. But graphically, this is going to be a slope. And let me just say this, you might not get this at first. On an x versus t. This is the slope on a v versus t. This is the area on a v versus t. And this is the area on a versus t. And when you have that, you've got everything you need. That's the good news. It's like, okay, it's new. Like, what? Okay, but that's all you need. And you'll be great. So let me redo this. Give myself some room. And I'm going to put this underneath here. And this is all definitely all typed out in the book. But so this is really the same as this. And this. Is the same as if I write it like this. So now we've got a lot going on. We've got our thinking about the motion. We've got the drawing the motion. We've got the beginnings of some algebra with units, and then the graph. That's why physics is so hard, because you're talking about the same thing all these different ways. Feel free to interject, AJ, if you got a question or if anything comes up. So, average speed is useful, you see in this at the beginning of the chapter, but this is going to be really our focus as we move on quite a bit. Now, let me talk about graphs in general, and then look at specific motion. And the only way to learn it is you can't stare at it, you can't memorize it. You got to do problems. It's the only way to learn physics. Only way to learn an instrument, you got to play it. It's the same thing for a sport. You know, you can yell at the pitcher, but can you pitch? Okay, so here's the idea with graphs in general. In math, they often draw it like that. Physics, we often put an arrow at here. We don't always. And that kind of tells us the plus. So let me point out something in general, and then we'll build up. So these axes, I could graph whatever. You could graph how much money you have versus time, which will probably go negative at some point if you're a student. You could graph anything. You could, I don't know, you can graph your mood versus time. You can graph how many things are in a room versus the position, or you just, you know, any sorts of things. And in biology, et cetera, you graph a temperature, the temperature and the position of something. So lots of things you can graph. So let's just notice something mathematically. If I call this, I don't know, I'm going to call it I. This is different than the book, but this is what we call the independent axis sometimes. And I'll call this D, the dependent axis. Doesn't matter. We don't have to overthink this too much. And you'll see we're going to come back to graphing X versus T, V versus T, and A versus T. That's really where we're going to go here. But in your other classes, again, lots of graphs because they're really useful. So if I look at some points, say over here, there's a point. And maybe there's another point. And some other point. So each of those points has two values. This has got an I value. That has an I value of 0. This has an I value of 0. And there's a D value. And so, you know, what does that point mean? Well, it means that you've got I1 at this value of I, that point has that value of I and that value of D. What does it mean? Well, I don't know. I don't know what I and D mean, but it means whatever I'm looking at. So I2, D2, I3, D3. So you can look at the points. That tells you how much of this and how much of that. Now next, you can look at, there's only 3 key things to look at. The next is looking at the slope or the average slope. Now, average slope between any 2 points is going to be the change, in this case, the rise, change in D over the change in I. And what it means well, look at the units. For example, this is position, and that's time. It would be change in position over change in time. What's that mean?
Is it velocity?
Yeah, average velocity. So if, however, this was time and this is velocity, it'd be change in velocity over change in time, and the slope would mean average acceleration. So it depends on what you're graphing. But even if you're not even doing kinematics, whatever you do, the slope is the ratio of this over that. Now, if, for example, you have these 2 points, I don't know what the curve looks like. It could go like that. It could go like that. It could do anything. Still, the average slope between the lines is as if the line was like this. So the change in this divided by the change in that. Change in D divided by the change in, I call it I. It doesn't matter which way you go. That's the average slope. If I did from here to here, then the average slope would be from there to there. The change in D over the change in I. And from here to here, it'd be like this. change in D divided by, which would be negative, over the change in R. So we just see it. Now there's something else called an instantaneous slope. Or really the slope at a point. And there we use calculus, so we could take a derivative. Like if the curve was actually like this, then at any point the slope kind of is changing. We don't have to worry too much about that.
So the average slope is pretty much like the displacement.
It depends on what, so the meaning, it just totally depends on what I'm graphing. I mean, it could be temperature and position. The change in temperature as I move down a stick. And we call it gradient. There's economic slopes. You know, so you just have to, and so we all, when you're graphing new things, you have to think about what does that mean? It takes you a while to get used to it, but then at least you go, oh, it means this. What is that? You know, why is that relevant? And sometimes it's not even useful, you'll see. But that's all slope is. And we're going to see, again, cases of X versus T, V versus T, and A versus T. That's going to be the focus in your physics class at first. And then you'll graph force versus time and force versus distance. A little bit of things. And you'll see what it means. But once you're used to just any graph, slope is the change in this, whatever that is, over the change in that. If you look at the units and you go, what does that mean? And then you read some more because you won't necessarily figure it out yourself. And you get used to it. So there's instant slope too, and that'd be the derivative with calculus. And at any point, the slope might be changing, but between 2 points, it's the average. That's all you need for now. AJ, you okay?
Yeah, sounds good.
Okay. So there's the points. What do they mean? I don't know. Well, what's I? What's D? That's what it means. What's the slope? I don't know. What are these things? And then the last one that we're focusing on is the graphical area, often called the area, but it's not a physical area necessarily. So when you read through the book, you'll see this over and over until you go, ah. And it's quite powerful. You'll be comfortable with this. So now, graphical area. The graphical area, and keep this. And what you learn, you know, you don't make it complicated at first. So your curve might look like, let's do it kind of simple. Go here, and then I'll go up here, and then I'll go here. Maybe I should have done that in orange. And again, on this, I have no idea what it means. I haven't even said what D and I mean, but the math is still the same. So if I look at the area here between the curve and this axis, I got that. So it's going to be the area between the curve and the I axis. I used I for independent and D for dependent. You don't have to worry about that, but if you saw that in math, it's going to be our t-axis. So often people want to call it the x-axis. And I think that's a problem in our math education to always call it the same thing. We need to be more flexible. Look at a lot of different situations. And so this area would be, for example, from here to here. This has no area because it's straight up. It's just going to be that part right there. And that would equal this value, which is D1, from there to there. That's D1. And then this would be the change in I. And it's a rectangle. So it would equal, or it would give us D1 times the change, oops, not change in T yet, change in I. From 1 to 2. Because it's just a rectangle. It's this much times that much. That's change in I. That's D1. When the curve gets not rectangles and triangles, then you can use calculus and lots of other ways. You won't be doing that. It'll be rectangles and triangles. Because you can do it straight away and you can kind of see through it. And then if you need to, you can do the other stuff. What does it mean? It means the units of D times the units of I. And once you know this, you know for everything. For example, if D is velocity and I is time, meters per second times seconds gives meters, and that's going to be displaced.
Oh, it's just meter because you cancel seconds.
Yeah. It's going to be meters. This is something that comes way too fast in all our physics classes because we just don't have time to do it right, but it's important. So it's like, well, learn it on your own. And a lot of people don't. And it's frustrating for you. But whatever it is, that's what that graphical area is. It's D times that change. Here, this is half of a rectangle. So it's half of this D value times the change in I here. So this would be change in I, and that would be D2. So that area would be 1/2 D2 times the change in I. Except, depending on how you do it, what you'll notice is that this D is a positive number. So you get a positive. What's it mean? I don't know, the units of this times the units of that, whatever that means. And you don't have to figure it out because we'll show you. You should just be a little comfortable. Down here, D1 is negative. So I'm going to get a negative value for an area, but it's not really area. What does it mean? Well, you got to do some exercises. Is that okay so far?
Yeah.
Kind of?
Yeah.
Just take,
Let's just, where's the 1/2?
well, I got the 1/2 because the area here is half of the whole rectangle. So this would be the area of the rectangle, and that's half to give the area of the triangle. Thank you for asking. Oh, your questions are great. You know, and sometimes honestly, it's like, you know, wait, where are my shoes? You know, you might ask something that's like you go, oh yeah, but you get lost because you're thinking hard about stuff. And as you move on, you have to know which professors you can ask and which professors you can't ask. Sometimes they can be lost in their research and whatever. And they may or may not be a jerk, but they can be a jerk when they're stressed out by their work. A little bit of the game. Okay, so we can look at slopes, which this would be no slope, zero slope, slope, negative slope, and area and points. That's it. Good so far?
Yeah.
I'm going to pause. I'm going to turn this one off and start a new video.